Good afternoon. Welcome to another session number 2, guys. I would start by apologizing for not uploading the previous videos. I've had a hectic week, guys. So yeah. Most probably today I will upload what the video once I'm recording for today's session. Okay. Without wasting any more of our time, guys, let me just get straight to the point, because like in the previous session, I gave you these 3 questions and I asked you to solve them as some sort of a homework of some type. Okay. So what is going to happen is I'm going to go through the solutions of these 3 questions and then introduce a new, or however, what do we call this? An alternative way of finding solutions for integration by parts. Okay. So can you guys hear me? If you can't hear me, please let me know and stuff. Okay. So in our previous session, we defined that we have the integration by parts rule, where we defined it as the integral of u dv, which is equal to u times v minus the integral of v e. Okay. And we said that we always choose our u to be a terminating variable. It's always going to be very important for you to understand what I mean by terminating variable. And you're going to see it by the next method that I'm going to introduce, that such a thing is called a terminating variable because of 1, 2, 3, and 4. Okay. But without wasting any more time, let's just go with it. Okay. So solving these 3 equations, integrals. Okay, I want you to look at the first one. I want us to solve this one. Okay, I hope you guys did solve these things, guys, because okay, please do change your names to student numbers, guys, because it will help with register taking. Okay, it will help a lot with register taking. So please do change that whilst you still have time, because I have to take a screenshot of all of these student numbers. Okay. All right, so let us just continue. I said I'm solving the first problem, right? They say maybe evaluate x ln x dx. Okay. So you remember what I said in the last session, guys. When you see a problem involving ln, you always choose ln to be u. It's important for you to do that, okay? Please, guys, do make sure that you do that. So we're gonna let u be equals to ln x, then our du is equals to 1 over x dx, okay? Meaning that the only part that is left is dv, and our dv is given by x dx, okay? X dx. So what's gonna happen is we're going to integrate on both sides, okay? And when you integrate on both sides, you're going to see that x is equals to 1/2 x squared d. See, guys, I make that mistake of writing. I enjoy this differentiating. Sorry about it. Okay. So from that, we have defined our u and our v. Now we have to find this part where we're going to multiply our u and our v minus the integral of our v times our du v. Okay. So what we are going to do is our u dv is given by our u is ln x, our dv is x dx, and then we have to multiply u and v. So what we're going to have is 1/2 x squared ln x, okay? 1/2 x squared ln x minus the integral of v which is 1/2 x squared, times du, which is 1/x dx. Okay. So if you guys don't understand anything, please. So let us continue. Let us continue this one. So what we're going to have is we're going to have 1/2 x squared ln x minus. So we're going to take out this, what do we call this? Constant 1/2. Now, as we take out that constant, we're going to see something that since this thing and that thing represent a variable x, we can just show that this thing is going to give us 1. Then we have x. From here, guys, I know you know how to. Should I continue with this? Because I feel like some of these questions are the questions which we have done indirectly, but the complexities, we have solved them to an extent that do not see any complexity. For instance, what is the integral of x? The integral of x is the same thing. So the integral of x is just 1/2x. Okay. But for purposes of that and the purposes of other people understanding, let me just continue with it. So I've got 1/2 x squared ln x minus 1/4 x squared plus c. Okay. So this is the final answer for the first question. Okay. Do you have any questions, guys? Are we all together? Do you all understand? Or please do let me know now. Okay, let me take a screenshot of this thing, guys. Check if you have a question. Okay, with you being fine, guys, I think that you are fine. Please don't forget that if you do have a question after the session, you can still ask. And there are people which they understand some of these things, they understand how to, they can still help us as well. Okay, so don't just die alone. Please. Okay, I'm going to ask you again. Please do change your names to student numbers such that it's take a screenshot and be able to submit your student number. Okay, so let us continue and do our second question. Let us continue in class. And remember, guys, I'm going to upload this video on YouTube today. So the second question says that we should evaluate x squared e to the x dx. Okay. So this is what's going to happen. When you're given something like this, I told you, we always take u to be a terminating variable. Okay. So in this case, we're going to let our u be equals to x squared. Then our du is equals to 2x dx. Okay. And then the remaining value is just going to be our dv value, which is e to the x dx, where our v is equals to e to the x. Okay. So as we know, by the rule of integration by parts, we have defined our u, we have defined our dv. Now we have to find u times v minus the integral of v times du. Okay. So we have our x squared e to the x dx. This is equals to our u times v is just x squared e to the x, because this is our u and this is our v, minus the integral of v, which is e to the x, multiplied by du, which is 2x dx. Okay, so now we have to integrate this part, but we can just write this as x squared e to the x minus 2 integral e to the x, or because I like it like this, just write this as x e to the x dx. Okay, so as you can see, guys, we still have another integration by parts here, so we have to redo this thing. But in this case, I told you that it is always safer not to use u and v again. So I'll just use a and b. Let a be equals to x, so our dA is equals to dx, and then let dB be equals to e to the x dx, then our b is equals to e to the x. Okay, so with the continuation of this, guys, now the integration by part only applies to this part. Okay, so what we're going to have is, I'm going to rewrite this as x squared e to the x minus the integral of e to the x. Hey, hey, hey. I nearly made a terrible mistake, guys. Okay, I only wrote this part. I forgot that we simplified it. Sorry about it. Okay, so in this case, remember we have got these two, and then we are going to say our a times b, which is the same thing as saying u times v. Our a times b is just x e to the x minus the integral of v du. Now v in this case is just dv, which is e to the x, and then our du is just x. Okay, and as I said to you guys, we think of a as u and we think of b as v. Okay, I just don't want us to use the same thing again and again. Okay, so this is what's going to happen. So we're going to have x squared e to the x minus 2x e to the x minus, now what is the integral of e to the x? It's just e to the x, so we have minus 2 e to the x plus 6, which becomes our final answer. Okay. Oh, and we said that we can check if this thing correlates to our problem. Okay, we can do that. To make this interesting, let me let you guys try to check if this thing is true or not. What I mean is that now you have to find the derivative dx of x squared e to the x minus 2x e to the x minus 2 e to the x plus c. Just find that derivative. And that derivative is expected to be equals to x squared e to the x. Okay, so I'll trust you guys to do this one. Okay, do we have any questions? Or should I check it myself? But I feel like when I check it myself, and it comes out, everybody likes it and stuff. Okay, but yeah, please do let me know, guys. Should I check it or should I leave it? You guys will be able to do it. Okay, you guys are awfully quiet. But it's okay. At the end of the day, it's okay. Or somebody says I should check it. Okay, so let me check it. So I need to rub out some here. Okay, so let me rub out this part here. This part here, because I believe like it's a part which we have put in this part. Okay, so the derivative of the first part is integration. Oh, it's a derivative using the product rule. So now we're going to have the derivative of this thing is going to be x squared e to the x, because the derivative to the x is just e to the x, plus, now we leave e to the x and the derivative of x squared is 2x. And then I'm going to say minus, the same thing applies for this one, guys, okay? 2 to the x is one function, e to the x is another function, meaning that now we're going to use product rule again. 2 to the x, e to the x, because the derivative e to the x is just e to the x, plus e to the x multiplied by a 2, okay? The derivative of 2x. And then this part here, we're just going to have negative 2 e to the x, because it doesn't change, okay? doesn't change at all. And then we have the last part, the derivative of constant is always 0. So therefore, what we are going to have is something of this nature. We're going to have x squared e to the x plus e. Okay, let me write it in the form of 2x e to the x, and then you're going to have minus 2x e to the x, and you're going to have minus 2 e to the x minus, I believe it's minus, yeah, minus 2 e to the x plus z. Okay, now you find it that idea, guys. Okay, so after here, we're going to realize that this becomes 0, but this does not become 0. Ooh. Okay, let me see where I made my mistake. Oh, I see where I made a mistake. Okay, sorry about that mistake, guys. You see that this is a negative times a negative. That's to be positive. That's to be positive. Sorry, guys. What's this? It should be positive here. Which changes here. So this and that becomes 0, and then our final answer hence becomes x squared e to the x, which correlates to our integral. Okay. I didn't see this one, guys. I forgot that this negative times this negative should give us a, I just became overexcited and didn't apply the correct algebra. Okay. It's my mistake, guys. Sorry about that. Okay. So we have checked and it correlates. So we can do the last question now. Do you have any questions so far? Is there anybody who has got any questions whatsoever? Okay, let me just grab this out as I'm waiting for the question. Let me just do this. Please take note of these signs, okay? These signs are very, very much dangerous, so we should take care. Okay, so let's solve the last question, and then we are going to introduce the tabular method, which is a nice method. Okay, so here we have got a very interesting question. I love such questions. These are such questions which you are going to get most of the time in your exam, okay? Where they are saying evaluate that. Okay, let me take a screenshot. So guys, please let me know how can I approach such a question. I know that in our last session we did something like this, and I hope we still remember. Okay. So I've got such a question. How do we approach it? Okay, it's fine. It's fine. We're gonna let u be equals to, we can choose between the two because these are non-terminating variables, okay? And then we're gonna have d. So we can choose anything. Which one do you want us to use is u, and which one do you want us to use is e? Okay, so they say I should use sine x as u. So our du is equals to cos of x, which means that the variables that are left, use them as x. Okay. Now, what we're going to do is we're going to substitute into this equation and find this right-hand side. Okay. So the right-hand side says that you should have u times e to the x sine of x minus the integral of u of v cos x dx. Okay. So as you can see here, we are still going to have integration parts. Now, okay, let me not spoil. I love such questions. Now we're going to let our a, okay, let me not use a, p be equals to let's say cos x again. And then now our dp is equals to negative sine x dx. Okay. And then pq, after there is q, dq is equals to e to the x dx. Then our q becomes e to the x. Okay. Then what we are going to have here is we are going to have a solution of e to the x sine of x minus, now this minus is this one. Then we have integration by parts where we multiply the two, e to the x cos of x minus the integral of e to the x minus sine x dx. Okay, so this is multiplication. Okay, this is multiplication. That, so what we are going to have is e to the x sine of x minus e to the x cos of x, and then we already have a plus. Do you see where this plus comes from? This times that, it becomes a plus, times this, it becomes a minus. Okay, it becomes a minus. So you have this minus e to the x sine of x dx. Okay, so okay, your question might be, why do we have a negative here after having this negative here? Because these times that should give us a positive. But here we do have this negative. When you take out this negative, it becomes a positive. Positive times a negative becomes a negative. Okay. So this is the part which I like about this question. Okay. Now we remember that this thing is e to the x sine of x dx is equals to e to the x sine of x minus e to the x cos of x minus the integral of e to the x sine of x dx. I forgot to write this one. Okay. So what happens is, do you see we've got common terms here? You can't say common terms, common terms. I'm going to take this one and bring it this side. Okay. Okay. After transposing, we're going to get something of this nature. 2 integral e to the x sine of x dx, because this and that, this becomes positive when it comes to this. It becomes e to the x sine of x minus e to the x cos of x. Now we divide each and every term by 2. Then our final answer becomes e to the x sine of x dx, okay, is equals to 1/2 e to the x sine of x minus 1/2 e to the x cos of x plus c. Oh, you don't see that that's part. Okay, just grab this one out, right here. Okay, so let me just remove the questions as well, because we are done with them. Okay, so the last part, which is this step over here, I'm gonna write this step as we divide each and every term by 2, so it becomes e to the x sine of x dx is equals to e over 2 sine of x minus e to the x over 2 cos of x plus c. Okay, I hope you are happy with that, guys. I hope you are happy with that. Do you have any questions for this one? Oh, we can check if it correlates to that, but already we know every time when we check, we're going to find the same solution. But for the purposes of me making mistake, let's check. Okay, so we have to find the derivative of this. Okay, so let me just remove this part. This part. Okay, just a small corner. Let me use this small corner to find and check if that is true. So this is how we check. We're going to find the dx of e to the x over 2 sine x minus e to the x all over 2 cos x plus c. Okay, so the derivative of this applies the product rule. So the product rule, what we are going to have here is e to the x. The derivative of sine x is cos x, and then you're going to have plus. Now we're going to leave sine x alone, but obviously the derivative of e to the x is just e to the x. Okay, and then we're going to have a minus. Okay, so I'm going to introduce this to show the difference. We're going to have e to the x and have this as a positive, as a negative sign of x, okay? Because the derivative, of course, is negative sign of x. And then let me just continue by here, plus, now we're gonna leave cos of x, but the derivative e to the x is just e to the x cos of x, okay? Now, as you can see from here, guys, we are going to have, guys, don't forget that there is 1/2 and also here. So let me just write it. Let me just write it here as 1/2 everywhere, okay? Cos of x. So there's 1/2 everywhere. Okay? I hope we can see this 1/2 comes from these halves. The c, we don't consider it that much because we know a derivative of a constant is always equal to 0. So that's why this 1/2 applies. Because if you can check well, when we wrote the solution, we must divide each and every term by 1/2. And when we do that, our c does not get affected. Okay. So what's going to happen is, I'm going to say, let us have 1/2. Okay. So we're going to have this e to the x cos of x plus e to the x sine of x. Then we have this becomes a negative times this negative becomes a positive, e to the x sine of x. Then this becomes minus e to the x cos of x. As you can see, this and that will give us 0. We have 1/2, 2 times e to the x cos of x. Then this times half becomes e to the x. No, it's not cos, it's sine. Where is it? Oh, I cancelled the wrong thing. It's sine. It should be sine. I get super excited in such questions. Okay. But today I'm making a lot of mistakes. E to the x sine of x. Okay. Because these values of sines are the only ones which are additive in this particular case. So this becomes sine of x, which is the same thing as our integrand. Okay. Sorry about that, guys. I got very excited to cancel the sine cos, not the same term, only the cos terms with different signs. Okay. I hope you understand that one. So without wasting any more of your time, do you have any questions so far, guys? And then you're going to be silent. Just okay. So I want us to do the last part of integration by parts called the tabular method. Okay, tabular method, which is my favorite part. Me, guys, I told you I like to have the easiest approach to questions. Okay, so I'm gonna show you the easy approach to this question of integration by parts. Suppose they say to you, find okay, let me find the integral of x squared sine squared 4x dx. It's going to be very interesting. It's a very interesting time. So let us look at this question. Okay, you have to use your value of u to be what we call it, some variable. Okay, some variable. I don't know which variable you can choose, but there are so many variables you can choose. But as I said, when you choose here, you must choose a terminating variable. Now, what is a terminating variable? It's a variable which, when you differentiate it after some number of times, it's going to give you a solution of 0. Okay. In this case, a terminating variable is x squared because we know that the derivative d dx of x squared is equal to 2x. Then you have to find the derivative of 2x, which is 2. Then you have to find the why am I saying partial? Guys, I'm sorry, I'm just enjoying the course of partial. Then it becomes 0. Okay. So once it becomes something of this nature, we call this a terminating variable. Okay, because its derivative will eventually get to 0. So in this method, we always fight to make sure that our terminating variable becomes the one, which is 0 variable. Okay. So are we fine with this idea, guys? If you are fine with the idea, please give me a thumbs up. And if you are not fine with the idea, you let me know. I'll try to do another example. Okay. Actually, I'm gonna do another example. So I don't know why I'm saying. Okay. Let me take a screenshot. Take a screenshot. Okay. So let us continue with this. I actually gave you a hint on how we're going to solve this. I don't know why I did that. But you're gonna let u be equals to x squared, and we're gonna let dv be equals to sine 4x dx. Okay. So our du is equals to 2x dx, and our v becomes actually we don't need to do this. Let me just now, because I want us to use a different method. We are going to find the final answer, but okay, with a very much different. So we have got our u, we've got our u. Okay, we've got our u, we've got our u. This dv simply represents v prime. V prime in this case is just okay. Don't need to write the dx. Our dv represents v prime. Okay. So because how do I say it represents the v prime? Let's divide both sides by dx. Right here by dx. dv dx is equals to sine 4x, and dv dx is equals to v prime. So as you can see, that's why I'm saying the v prime is just sine 4x. Okay. I didn't want to write this because I believe that you guys, since I've been doing this thing of differentiation, understand. Okay. So let us continue. Now we're going to write this thing called the tabular method. And in the tabular method, we have a side which we call the alternating signs. Alternating signs. Okay. And we have got a side which we call u and its derivative. Derivative. Some people will call it different ways. It's fine. It doesn't matter. It doesn't actually play a huge role. And its antiderivative. And its antiderivative. Derivatives. Okay. So what happens is all the time when you start using the tabular, you always use the sign of plus. Okay. Then it will alternate to a minus. Then it will alternate to a plus. Then it will alternate to a minus, so on and so on. Okay. I hope you understand that. It always comes like that. Okay. Now, the first step that you have to do in this case, you have to write u the way it is. So it's going to be x squared, okay? And then this side, you have to write the sine 4x, which is sine 4x. Now, the nice part starts. What is the derivative of x squared? Is 2x, okay? What is the integral of sine 4x? Is negative 1/4 cos 4x, okay? Then we go and we say, okay, what is the derivative of 2x? It's just 2. And then what is the integral of this one? It's just negative 1/16 sine 4x. Okay, this is just integration. This is derivatives, differentiation. What is the derivative of 2? It's just 0. So we stop here in this case. So we don't consider what happens. So we stop here. And then what is the integral of this? Integral of this must be 64 cos Okay, please check if this is true. Okay, I want to see something. So I must have 1/16 times 1/4. So 60 times 64. 4 yeah, 4 times 1 is 4 plus 2 is 64. Yeah, so it's correct. So it's correct, right? And we know that a derivative of this one will give us this one. Okay. So what happens is now, since we have this zero term, there is no other term that we can have after the zero term. We stop here with our differentiation. Okay. So obtain anything above the zero. Once we have obtained the zero, which means we are at our answer, then therefore, the final answer for this thing, x squared and 4x dx is equals to, now this is the part that gets very interesting. I love such things. We are going to multiply this term by this term, then multiply this term by this term. Okay, then the same thing applies. We multiply this term by this term, then this term by that term. Multiply this term by this term, then this term by that term. Okay, so therefore, what we are going to have, we're going to have such a, so we have this multiplied by x squared multiplied by a negative 1/4. So we're going to have negative 1/4 x squared cos 4x. Okay, then the next one is what? Negative 2x times negative. So it becomes a positive 1/16 2x sine 4x one. Then a positive times a positive, positive, everything is positive, so it becomes 1/64 cos 4x plus c. This becomes a one part. And we have solved this equation by parts, but in this case, in the tabular method. Okay, so we've got less than 1 minute